Hello, this is your teacher David Garcia, and today we're going to learn how to write the standard form equation of an ellipse from vertices and foci. Now, if you remember, the first thing we have to do is to identify if we are dealing with either a horizontal or a vertical ellipse. Now, from the previous video, we know that if when given vertices, we have the same horizontal coordinate, that means that we're dealing with a vertical ellipse. So this will be one of our vertices, and here's the other one. So let's call this 1, 5, and this will be 1, negative 13. Now, the next information they give us are the foci. The foci, all right, will be around here. That's extra information. We know that the center is around here. So as we have determined that we're dealing with a vertical ellipse, let's focus on how to get the equation. Have it over here. And how to get all the variables. So we already have h. H is 1. Okay. Again, because it is given to us by the vertices. And if you see, the foci also share the same value. Okay, so it only stands to reason that h has to be 1. Now, if you remember, the foci on a vertical ellipse are determined, or the coordinates for the foci are determined by h, k, plus and minus c. So if you pay attention to this, they're already given us the value of k, because k is being modified by addition and subtraction of c, which is the distance from the center to either of the focus. So let's go back here. There we go. We already have k as well. So we have the coordinates of the center. Now, we need to calculate A, we need to calculate B, but they are already given us C indirectly, which in this case is the square root of 77. Now, let's just identify the distances. We know, sorry about that, we know that A will be the horizontal distance from the center to the covertex, in this case, and B will the vertical distance from the center to, let me just arrange this, there we go, to the vertex. So in other words, A will be the change in x. But now we have a problem because we don't have the coordinates for the covertex. Now let's take a look at B. B is the change between the vertical coordinates, which in this case we do have. It'll be the distance from, sorry about that, -4 and 5. So 5 minus -4 is 9. So we already have the distance for B. Now, if you take a look at your formulas, there is a relationship between these three variables, A, B, and C. And it is based on the Pythagorean theorem. In this case, the formula tells us that whenever we have a vertical ellipse, C will be equal to the square root of b squared minus a squared. So if you see now, we have the value for C, we have the value for B, so it's just a matter of isolating A. So let's isolate step by step. C squared will be equal to b squared minus a squared. C squared plus a squared equals b squared. So finally, a squared will be b squared minus c squared. We get a square root on both sides. So we have that a will be the square root of b squared minus c squared. So now it's just a matter of substituting the values. We have that a will be the square root of b squared. If you see b is 9, we have it over here. So 9 squared will be 81 minus c, which is the square root of 77. C squared will be 77. So 81 minus 77 is 4. The square root of 4 is 2. So now we have the value for a, which is 2. So now we have all 4 values required to write the equation. So now it's just a matter of substituting them. So we will have x minus 1 squared divided by 2 squared, which is 4, plus y minus negative 4, so y plus 4 squared divided by b squared. 9 squared is 81. This equals 1. And this is the answer that we were looking for. There we go. So thank you very much and see you the next class.